All right, so so it told us that we have these 2 points, P1 and P2, and that it wants to know what the halfway distance would be between the two. So let's see, Dahlia, can you tell me what method you used to figure this problem out?
I started with the distance formula.
Good. So the distance formula is
Square root of x, well, in parentheses, x2 minus x1 squared plus.
so 2 minus 3
Mhm.
squared. Okay.
And then 3 minus 2 squared. And plus 1 minus 1 squared.
Good. Oops. Okay, so now when we simplify this, what did you get, Caroline?
I got square. Okay, so I did for the first one. I got 1 plus 1 and then plus 0.
Good. So your final answer should be
The square root of 2.
perfect. Good job, Caroline. And then Alston, it asks us for the halfway distance. So is this our final answer?
No, it is the square root of 2 over 2.
Good. So half the distance is going to be, we want to divide our total distance by 2. So we would take the square root of 2 and divide it by 2, and that will be our final answer. Okay, what questions do you guys have about that warm up before we move on? Okay, so this flashing is driving me nuts. So let me switch something real quick. And then we are going to take some notes today. These notes are just on notebook paper. You don't worry about like needing to print anything out. You should be able to draw everything. I'm going to be drawing everything with you. So today we're doing notes, and then we have an around the world activity, which I'll explain when we are done with notes. And then you have homework. And then I don't know if you have signed this already. I got an email last week and then forgot about it. It was an IB academic honesty policy Google form. Have you guys signed that already in a different class?
No.
Okay, well, I linked it in activity 1. So I have the list of asynchronous activities for you guys to do today. And it should be the third activity on your asynchronous list. And it just has link after it. If you'll just click on that and see and fill it out. Are you guys part of like an IB Canvas module or Canvas class?
Yeah.
Okay, so I think that the academic honesty policy should be on there somewhere. So look through there, make sure you've read the policy, and then go and fill out that Google form. We have done an academic honesty activity, and I believe you guys submitted it with parent signatures. Is that correct? Or with your signature? Did we do that in our class?
I don't know.
Okay, well, I'll go back and look, but we'll just go ahead and do this official one to make sure that we've got all of our bases covered. Okay, so that's it for today. So we're going to go ahead and take some notes. And we're doing arcs and sectors today. So had I been more, I don't know, less scatterbrained last week, we would have probably already done a quiz over midpoints and surface area and volume. But it kind of works out. We're going to do it on Thursday. So you have a quiz Thursday. I think I sent you guys a message about it, and it's going to be over the stuff before arcs and sectors. So this that we did last week. Then once we're finished with arcs and sectors, we're going to go ahead and have a mini test just to get you guys used to the IB testing style. I will give you a full 90 minutes to do the mini test, but it will be shorter than I would normally make it, just to get you guys used to it. Also, for both your quizzes and your tests, you need to have a parent or guardian present and sign the bottom of your test or quiz, saying that you followed all of the rules that are going to be written at the top of the quiz or test. So in your IB classes, we like to practice using IB policies. And so all of it needs to be written in pen. Even though I'm not there to really check and see if it's written in pen versus pencil, there are sections where you can use a calculator, sections where you can't, and there's this very specific time limit for both quizzes and tests. So yes, so you will need to have a parent or guardian present when you take it, and you need to have them sign the bottom of your quiz or test saying that you followed all the rules. And we'll go over that again on Thursday when we actually take the quiz. Okay, so when we talk about arcs and sectors, we are talking about arcs and sectors of circles. So draw a circle at the top of your paper. And a sector is like a section of your circle. So this is a sector. This whole little, it's like a pie piece, a little wedge of the circle. And then your arc is the arc that goes along the perimeter of your circle. Okay, so this is what we're talking about when we're talking about arcs and sectors, specifically of circles. So there are two formulas that you need to know. So for your arc, the length of the arc is going to be r theta. Theta will be this angle right here, okay? R is your radius. So R is your radius. Theta is your central angle. Okay. Now for sectors, so arcs, we were looking at length. What's the word? What type of thing do you think we're looking at for sectors? So we looked at lengths for arcs.
Area.
Yeah, we're looking at area for sectors. So the area for our sector is going to be equal to 1/2 r squared theta. Again, r is your radius, theta is your central angle. Okay, also your central angle always has to be in radians. Okay, do you guys remember how to convert back and forth between radians and degrees? Let's see. Ethan, do you know how to convert between degrees and radians? It's okay if you say no.
Yeah.
Okay, so if I start in degrees, what do I do to get to radians?
You multiply by pi over 180.
Very good, thank you. So you multiply by pi over 180. Okay, so make sure you know that and are able to do that. Okay, does anybody need a minute to catch up writing, or is it okay if I go ahead and start with an example? Okay, I'm going to assume that means I can go ahead and do the example. Okay, so I'm going to give you sector OAB has radius 5 centimeters and a central angle theta of 40 degrees. First, I want you to find the length of arc AB. Okay, and second, we're going to find the area of sector OAB. Okay, so the very first thing we need to do, because we're going to have to use our central angle no matter which part we start with, is we're going to go ahead and convert that angle 40 degrees into radians. Okay, so I'm multiplying by pi over 180. And Imani, can you simplify that for me? 40 times pi over 180. What is that going to give me?
I don't. Let me put it on the calculator.
So what's half of 40 and half of 180?
20 and 90.
So we can have 20 pi over 90. Do you see how to simplify it even further than that? There's a factor that can come out of
2 pi over 9.
Yeah, very good. 2 pi over 9. We took out a factor of 10 from both the top and bottom. Very good. So we have 2 pi over 9 radians is our central angle. Okay. And for part A, let's see. It asks us to find the length of arc AB. So Samuel, using the equation that we were given, what would we write down? What would our arc length be?
Well, I did, so it's like radius times the angle, so it's 5 times 2 pi over 9. So I just left it as 10 pi over 9.
Perfect. And what would the units for that be?
Oh, it's what is that? Is it just radians?
It's arc length, right?
Oh, yeah.
So what is the unit for our length?
Just centimeters.
Yeah. Good. Okay. And then part B, let's see. Heath, we're looking for the area of sector OAB. So using our area formula, what am I going to write down?
1/2 times 5 squared, and then multiply that by 2 pi over 9.
Very good. And when I write out my final answer, what am I going to have?
So 5 squared is 25 times 1/2 would be.
Well, hold on. Before we multiply by 1/2, notice that we have a 2 in the denominator and a 2 in the numerator. What can happen?
Those cancel out.
Yeah, so then we don't have to do any extra multiplying.
So then you just have 25 times pi over 9.
Yes, I started writing pi. I should have.
And so the final answer would just be 25 pi over 9.
Yes, what are the units?
That would be in centimeters squared.
Very good, because it's area. All right, questions on that example before we move on? What questions do you have? All right, thank you, Heath and Samuel, for helping me out with that, and Imani for helping me out with the central angle. All right, so I'm gonna flip over. We're gonna do 2 more examples, and then we're gonna talk about 2 other types of questions that IB might ask for, because although these seem very simple right now, IB can make it more complicated. Don't underestimate. So for the next one, we have the sector of a circle of radius 3 centimeters, subtends